we have buy and sell stock coding challenge. So in this interview question, we could be asked to construct a function that would accept an array of integers which represents stock prices. So we have one stock, and indices represent days. So this is day 0, and at day 0 the stock price is evaluated to $2, right? And on day 4 it's $4 and so forth. Cool. And what we need to return is max profit. So this profit can be either 0 or integer that is greater than 0. So in our case, the lowest price, so we can buy stock is at 1, and the best time to sell the stock is at value 8. So our max profit in this case would be 8 minus 1, which is 7. Cool. So we can take you can pause the video and try to solve it on your own. Yeah. After that, we can do it together. So one way of solving this would be to have 2 for loops. So we have one loop here. So this is for the day when we buy stock, and other days are potential, also the days when we sell the stock. And we're basically looping, having outer loop and inner loop, and we track the max profit. Right? That would be our brute force solution. And in terms of time, this would give us, so we have basically 2 loops. It's n times n, so it's n squared, right? N is the number of elements inside an array, and for space we wouldn't be using any additional spaces, so it's constant, right? So this is one way of solving this problem. We could probably optimize this. So let's say that we have a variable called lowest price, lowest, yeah, which could be initialized to so the first price, which is 2. We would also track the max profit, which could start at 0 or negative infinity. In this case, we would just start at 0 and current profit, like so. Cool. We start at the beginning of the array, and we have the price 2. So current price, which is 2, minus lowest price 2, profit is 0, so we don't need to do anything. For the next day, we have stock price that is $1. So 1 minus 2 is minus 1. It's not bigger, so the current profit would be minus 1. So it's not bigger than what we currently have, which is 0. But the lowest price is smaller, so we need to update this. We can move forward. 2 minus 1 is 1, so current profit is 1. Current profit is bigger than what we currently have saved in max profit, so we can update it and move forward, right? And so forth, right? 4 minus 1 is 3, so the current profit is 3. 3 is bigger than max profit, we can update this as well, and so forth. Do it for the rest of the stock prices here. So in terms of time space complexity, so for time, we're just going through each stock prices, so it would be of n. And space, we're just saving few variables, so it's constant space of 1. Cool. So let's look how this would look like in code. So we have these stock prices here. We'll have a method called profit. Let's just for fun, let's do the brute force solution first. So for I in range length A, so we have outer loop, and then we can have inner loop as well. But this inner loop starts as I plus 1 and ends here. And our current profit can be, so the selling point is J minus I, like so. Max profit can be 0. And then on each stage, we can say max profit equals max between max profit and current profit, like this. And after we're done with all both loops, we can just return max profit, right? If you run this code, we should get back 7, which we do. Cool. Again, this is brute force approach, which has O of n squared time with O of 1 space. Let's do a better solution. This will be more optimal solution in terms of time. We need to track, so we need to have few variables. So max profit, which starts at 0. What else? Oh, we'll see. For current in array. So this is current number. So lowest price can be just the first element inside an array, and profit can be so current price minus lowest price. And now we need to update our max profit, which is max between max profit and current profit. After that, we need to update lowest price, which is minimum between lowest price and the current price, like this. After we're done, we just return max profit, like so, right? If we clear the output and run the code, it should still work. We get 7. Cool. Now, this solution is a little more optimal than than our brute force solution. So we're going through all of the elements just once here. We can say our runtime is O of n, right? And for in terms of space, we just have 1, 2, 3 variables, so it's still constant. So space, it's O of 1, like so. Great. Yeah, so that's about it. Till next time.